Welcome to Study Loop.
In this problem, we have to write down the equilibrium constant expression for each of the reactions given, and then we will have to say whether the reaction is homogeneous or heterogeneous. So we start with the first reaction here, which is 2O3 in gaseous condition is producing 3O2 in gaseous condition. So the equilibrium constant expression for this one will be, as you know, that equilibrium concentration is the product concentration with a power as the coefficient, or the coefficient as the power, and in the denominator we have the reactant concentration, same as the coefficient as the power. So this is the equilibrium constant expression for this reaction. Now, whether reaction is homogeneous and or heterogeneous depends on the phase of the reactants and products. If all the reactants and products of a reaction are in same phase, like for example the phase is whether the reaction is gaseous, liquid, solid, or aqueous. So if all the reactants and products are in same phase, that means that is a homogeneous reaction. And since here our both of the reactants and products are in gaseous phase, that means this is a homogeneous reaction. Now in second one, we're given a reaction of titanium reacting with, which is a solid, reacting with chlorine, which is gas, to give us TiCl4, which is liquid. Now from here, our equilibrium constant expression will be product over reactant again, but in this case the product is a pure liquid. So as we know that in equilibrium constant expressions we do not include liquid or solid components of the reaction. We just include gaseous or aqueous components. That means TiCl4 will not be included. In that case, in the numerator we'll just write 1, and in case of the reactant, since titanium is a solid, it will not also be included. That means we will only include the chlorine concentration, and since we have 2 chlorine, it will be powered by 2. So this is the equilibrium constant expression for this reaction. Again, since we have different phases present here in the same reaction, we have solid, gas, and liquid. That means this is a heterogeneous um, reaction. Then in C, we have 2C2H4 in gaseous condition reacting with 2H2O, which is also gas, will give us 2C2H6 gas and O2, which is also gas. So here we don't have any pure liquid or solid. That means our equilibrium constant expression will include all the components. In the numerator, we will have the product concentration C2H6 square for the for the coefficient of 2, and we have times by the O2 concentration. And in the denominator, we will have the reactant concentrations. We have 2 of the C2H4 times we have 2H2O. So this is the um, equilibrium constant expression for this reaction. Again, in this reaction we have all the components in the same phase, which is gaseous phase. That means these are homogeneous. This is a homogeneous reaction. Then in D we have solid carbon reacting with hydrogen gas to give us methane gas. Again, in this case, the Kc will be the product concentration over reactant. Product we have methane gas. Reactant we have carbon solid, so we will not include carbon. We will only include the hydrogen, and we have two hydrogen. That's why it will go as a power. And again, here we have the components in different phase. We have solid and gas. That means it is a heterogeneous reaction. Then in E, we have 4HCl reacting with oxygen gas to give us 2H2 and 2Cl2. Now the equilibrium constant expression for this one will not include H2O because it's a pure liquid. So we will have only chlorine concentration as the numerator and 2 as its power, since we have two chlorine molecule, and in the denominator we will have HCl. It will be powered by 4 and we have O2. So this is the um, equilibrium constant expression for this reaction. And again, here we have multiple phases of the components in this reaction. That means this is a heterogeneous reaction. Now, then in F we have octane in liquid condition reacting with 25 oxygen molecule to give us 16 CO2 and 18 H2O. So the equilibrium constant expression for this reaction. So uh, just look that for this H2O, normally H2 are in liquid condition, but in this kind of combustion reactions of organic compounds, the H2 will always be in gaseous condition or in steam condition. That means just make sure you don't mess it up here. So H2 will be included in this equilibrium constant expression since it is in steam or gaseous condition. So we'll write down CO2 concentration powered by 16, since we have 16 CO2, and then we have 18 H2O. And the denominator will have, so since octane is a liquid, it will not be included. We'll just include the oxygen. So we have 25 oxygen. So this is the um, equilibrium constant expression for this reaction. Again, we have multiple phases here. We have liquid, we have gas. So that means this is a heterogeneous reaction. Finally, in Z, we have 2H2O. Oh, no, it's 2C8H18 in liquid reacting. So this is the same reaction as the previous one, but there is just only one change here, which we have already talked about. 16 CO2 plus 18 H2O, and the H2 here is a liquid. So that is the only change from the previous reaction. So in this case, the Kc will not include this H2O because it is in liquid condition. So we'll just include the CO2 as the numerator and As a denominator, we will only include O2 since octane is still a liquid. So this is the equilibrium constant expression for this reaction. And again, we have liquid and gases. So that means multiple phases. And that's why it is a heterogeneous reaction.